Okay, fifth graders, today is Wednesday, December 11th, and we are learning about Eureka Math Module 3, Lesson 3 today. And fifth graders, as you can see from our learning goal today, we are adding on to what we did yesterday. We are still adding fractions, but there is one word that is different from yesterday's learning goal. Today it says I can add fractions with unlike denominators. Yesterday we added fractions with like denominators, which means that the denominator was the same. So today, if we are adding fractions that have unlike denominators, that means that today the denominators will be not the same or different. Good. As a quick review, I'm going to ask you guys some questions. Just shout out the answers, okay? If I have one adult and I add 3 more adults, what do I have? 4 adults. So if I have 1/5 and I add 3/5, what do I have? 4/5. What is the same about these questions? Well, in both cases, the units are the same. Adults is the same as adults, and fifths are the same as fifths. Do you guys see that? Okay. Now, what if I have one child and I want to add 3 adults to it?
1 child and 3 adults.
Do you see how you can't combine it into 4 of anything? It has to be 1 child and 3 adults.
4 people.
4 people, but you had to change the units, right? Because in this case, a child and an adult are different units. Similarly, what if I have 1/5 plus 3/3?
1/5 and 3/3.
See how you have to say it as 1/5 and 3/3? You can't say it as 4 of anything. Why? Because the units are different. So what I want you to write down in your notebook is that we need to make like units before we can add. If we have 1/5 plus 1/3, we do not have like units because one of the units is fifths and one of the units are thirds. Are fifths and thirds the same thing? Are fifths and thirds the same thing? No, they are not like each other. They are unlike units. So every time we're working with fractions, when we want to add or subtract fractions, we always need to make them into like units before we can add. Remember that like means that the denominator will be the same. Of course, we can use numbers to help us make like units, but today we are going to be using the strategy of using pictures. And to be specific, we are using rectangular fraction models. Okay, so today's going to be one of those days where it might be a new strategy for everyone in this class, which is great. So you're going to have to follow along exactly as I do. And I'm going to explain to you why I do it the way I do it, okay, for you to understand this strategy. So the first problem we're going to think about is 1/2 plus 1/4. Go ahead and write that into your notebook. 1/2 plus 1/4. Do I have like units here? No, because what's the units of my first term? Halves, and the denominator's too good. And what kind of units do I have for my second term? Fourths. Halves and fourths are different. They're not the same. But so in order to add them up, I have to make them into like units, okay? And here's how you can make them into like units using pictures. First, you're going to draw a rectangle, and you're going to label that rectangle is one whole. Go ahead and do that first. Then you're going to cut it in half vertically and shade in half of it. So you show that all together there are 2 parts, 1 part and 2 parts, and one out of the 2 parts is shaded. So you can draw brackets to show that this shaded part is 1/2 of the whole rectangle. You'll notice that I cut it in half from top to bottom vertically. Could I have cut it this way too? But I didn't. Okay, good. Now, our second term is 1/4. Again, you're going to start by drawing a rectangle and showing that entire rectangle is worth 1. This time I'm cutting it into 4 equal-sized portions because I know I want 4 equal-sized portions. My units are fourths. Yes? And I'm going to draw them horizontally this time. I'm going to shade in 1 out of the 4 sections and use brackets to show that shaded in part is 1 out of a total of 4 sections. The reason why we're drawing the first term vertically, and the second term horizontally is because in order to make like units, we're going to overlap them. Let me show you. Here I have half, right? Imagine that this is 1, and here is half. Do you guys agree? Okay. And then, give me a quick second to do something. Okay. Now, I'm going to have another unit. That's still 1, and I'm going to draw it horizontally. Right? And this is 1/4. Do you guys agree? Now, to make like units, what I can imagine is that I'm overlapping them. Now, how many sections do I have altogether? 8, right? It would be like I took these horizontal lines and drew them this way. And over here, it'd be like I took the vertical line and drew it this way. Now, let's take a look at the 1/2. Instead of 1/2 now, how many total sections are there in this whole?
5.
No. How many total sections are there in this whole? 8. 1, 2, 3, 4, 5, 6, 7, 8. So I can say that 1/2 equals something over 8. How many sections are shaded in? 4. Let's take a look at the 1/4. How many sections are there altogether now in that one whole rectangle? 8. Still 8, right? Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8. Do you guys see that? So that means that my new denominator is 8. How many of those 8 sections are shaded in? 2. What this means is that 1/2 is equivalent to 4/8. Do you guys agree? Did I change how much was shaded in that first rectangle? No, so it's equivalent. 1/2 is equivalent to 4/8. 1/4 is equivalent to 2/8. So I can rewrite my addition problem. Instead of writing 1/2 plus 1/4, I can write 4/8 plus 2/8. Did I change the problem at all? No. I just changed the way that the fractions were written. Now those fractions have like units. Do you guys agree?
Yes.
Okay. And so, if I have 4/8, now I can add. If I have 4/8 and I want to add 2 more 8s, how many 8s do I have altogether?
6.
Okay. Now, if you look at where I overlapped the drawing down here, you see that only 5 8s are colored in. Why is that? I'm going to unoverlap them for a second. I had 1/2 plus 1/4, and I overlapped them. How come the answer isn't 6 8s? Do you guys see how in this bottom section right here, there's 2 areas of shading? They got overlapped. So really, one more needs to be shaded in. Do you guys see how there's 6 8s there? Okay. But we're not actually going to think about overlapping too much. I just wanted to show you why we're going to draw one using vertical lines and the second added using horizontal lines so that we can think about overlapping them. When I overlap them, that's how I make my like units. When I overlap the halves with the fourths, that's how I got 8 equal sized sections. Do you guys see that? Let's try another example to make this even more clear. Let's talk through this problem together. We have 2/3 plus 1/4. Do I have like units? Yes or no? No, because my first units are what's? Thirds. And my second units are?
4.
Okay, so we have to somehow rewrite this problem so we have like units. Let's start by drawing rectangular fraction models. Rectangular fraction models start with rectangles. We show that this entire rectangle is one whole. Our first addend is 2/3. So I can show 2/3 by dividing it into thirds and then shading in 2 of those thirds. Do you guys agree? And I'm going to use brackets to show that this is 2/3. I always like to label my drawings, and you always need to label your drawings because sometimes your drawings might not be clear, right? Is that exactly 2/3 of my whole? No, I just eyeballed it. I just estimated it. So I can make sure it's clear to my readers by labeling it. Okay, now I want to add to that 1/4. So I'm going to draw another rectangular fraction model. I'm going to label it that is one whole. And I'm going to use horizontal lines to cut it into how many equal sized sections? Everyone? 4. I know I need to cut it into 4 sections because my denominator is fourths. So 1, 2, 3, 4 sections. How many should I shade in? 1. Good. So I'm going to shade in one of them. I'm going to use brackets to label that this is 1/4. Now, in order to rewrite 2/3 and 1/4 using equivalent fractions that have the same denominator, I have to think about overlapping them. So what I'm going to do is I'm going to end up drawing those 3 lines going horizontally there, and these lines going this way. Okay, now let's take a look. How many total sections did I cut this one hole into now? There's 3 going across and 4 going down. So that means that there are 12. Good. So the 2/3 is going to equal some number of 12ths. Did I change how much was shaded in? No, I didn't change the shading at all. So how many sections are shaded in? 8, right? Because I cut those 2 sections into 4 each. So 2 times 4 is 8. Do you guys see how basically I took each section? Like, think about this row. It used to be 1 row only, right? Now it's 4. The second row used to be only 1, and now it's 4. So did I multiply everything by 4? 2 times 4 equals 8. 3 times 4, right? So I basically multiplied it by 4 over 4. Good. Okay, now let's look over here. How many sections are there altogether here? Again, it's 3 by 4, so that's
12.
Okay. Did I change how much was shaded in?
No.
No. So how many now are shaded in? 3. How come before there was only one section shaded in, but now there's 3? Well, because I cut that one into 3 different parts, and I cut this one into 3 parts, 3 parts, 3 parts. So really, I'm doing 1/4 times 3 over.
3.
You guys see that? Good. Okay. But they're equivalent, right? Did I change anything about my drawings besides adding extra lines? No. Okay, so how can I rewrite this problem using like denominators? 2/3 plus 1/4 is equal to, Nadav?
8/12 and 3/12.
8/12 plus 3/12. Good. Now do I have like units? Yeah. Now my units are 12. So I have 8/12 and I want to add 3 more 12s. How many 12s do I have altogether?
11, 12.
So therefore, 2/3 plus 1/4 is equal to
11, 12.
11/12. Good.